Introduction to interacting with smart contracts. Interacting with deployed smart contracts involves calling their functions to read data or execute state-changing transactions. Understanding how to interact with smart contracts is crucial for building decentralized applications, apps. Interacting with smart contracts is like using a remote control to operate a device where you can send commands and receive feedback. Setting up the development environment. So you have three steps here, right? We have gone through the first two steps in detail in previous videos, right? I'm pretty sure in the last video also we did this. Yeah, so the first step would be to install Node.js JavaScript, right? Then you're installing NPM. NPM, as you know, Node Package Manager, right? And then finally, you're installing web3.js by using npm install web3. We have done this before, right? This is how you set up the development environment. So this is essentially like preparing your tools and gadgets before using a new electronic device, right? So whenever you get a new electronic device, before that, you prepare your tools and gadgets. That's how this is essentially. The necessary steps include installing Node.js and the Node Package Manager (npm), followed by installing the web3.javascript library. Cool. So next is reading data from a smart contract. So what is reading data from a smart contract, right? It involves calling view or pure functions. What these are? These do not modify the blockchain state and do not cause gas. Be very careful. This is what a view or pure function is. It will not modify the state of the blockchain and it does not cause any gas. So reading data from a smart contract is like checking the status or settings on a device without making any major changes, right? So next go through an example code, right, for reading data. So this is a Solidity contract that demonstrates how to read data from a smart contract, right? So I'll go through this code. It should clear a lot of things for you. So first Solidity 0.8.0, everyone knows this by now, I'm pretty sure. Next is just defining my contract, right? Next is your state variable, which is string public message. State variable named message of type string. And public ensures it's accessible outside the contract. And this automatically creates a function for it, a getter function for it, by the way, right? So anyone can read the value of message without needing an explicit function to do so because it's public. Okay. Next is your constructor. So it's a special function which initializes the contract state. You must have seen this in other languages. We have done constructors before too, right? So this sets the state variable message to the value of underscore message, right? Okay. So next is your function definition, which is get message function. It's a public function accessible outside the contract. View indicates, again, as I said in the very last slide, right? View indicates the function does not modify the state of the contract, meaning it only reads from the blockchain and does not write to it. So this returns string memory, right? The function returns a string stored in memory, and the function body return message returns the current value of the message state variable. Right? So I hope you understood this code. So again, small quick explanation. We have my contract with the message variable that is set in the construct. So yeah, this is what the lower part also says. We have a my contract, the message variable that is set in the constructor. We have the get message function to read the value of message variable from the contract, and to interact with this contract and read the message value, you would use the get message function, which returns the current value of the message, right? Yeah. So that's it. So right, this is JavaScript code example for reading data. Already contract that demonstrates how to read data from a smart contract, right? Okay, so let's go through this. First, you're importing a Web3 library, right? And this imports the Web3.JavaScript library, which allows you to interact with the Ethereum blockchain from JavaScript, right? Next, you're creating a Web3 instance. We have already done these, right? You have already seen these mainnet and Infura.io. What this is it initializes a Web3 instance connected to the Ethereum mainnet via Infura, which was just a popular service providing access to Ethereum nodes. And be careful, your Infura project ID should be replaced with your actual Infura project ID. Next is contract ABI and contract address. Contract ABI is an array that contains the ABI, and again, ABI is just a JSON representation of the contract's functions, events, and data type, right? It allows the web3.js to interact with the contract. And contract address is the Ethereum address where the contract is deployed. And please make sure you replace these, what name they have given, with your actual address and your actual ABI, right? Okay. Next, you're creating a contract instance, right? So new web3.eth.contract, contract ABI, contract address, right? This initialize a contract object with specified ABI and address, allowing you to call its methods and interact with it. Next is a function to read message, right? So explanation, async function read message declares an asynchronous function. What is an asynchronous function, you might be asking? It just improves the speed of the program, right? Asynchronous programming allows the program to run multiple processes at the same time, even though they might take different periods to function, but it helps the program complete its processes much faster. Okay, so we are done with this, right? Next is just await my contract dot methods dot get message dot call. So be careful, go through this carefully. Calls the get message method of the contract and waits for the result. The call method is used only for read-only operations. Then you're logging it, right? Console.log message message prints the retrieved message into the console, and you're calling the function with read message, right? So this is it essentially. Let's go to the next one. So writing data for a smart contract involves calling functions that modify the blockchain state, right? Right now we were only doing reading. These were not modifying the blockchain. These ones modify the blockchain state and they require gas and must be signed by the sender. So writing a smart contract is like using a remote control to change the settings or the state of a device, which requires permission and may have a cost, right? You have a device, you're using a remote to change the settings, you're changing the channel on a TV, right? You're turning it from on to off. This requires permission that the owner should give you permission for this, and these might have a cost, which is in blockchain gas fees. Okay, let's take a sample code for writing data. We are done with reading data, so we'll just go through writing data too very quickly, right? Again, this, we are defining a contract, my contract, state variable, string public message, as I told last time. Constructor is also initializing, right? It takes one parameter underscore message, which is the string stored in memory. The constructor sets the state variable message to the value of underscore message, right? So here's the function, right? So the function is where it gets different. We're defining a function called set message. Okay, so function set message string memory underscore message. This declares a public function that takes one parameter, the underscore message, which is a string stored in memory, and the function message equal to underscore dot message updates the message state variable with the new value provided by underscore message. Here you are writing data, right? So in this, your my contract has a message variable that can be used using the set message function. Starts by defining the solidity, declares my contract, which has a message of variable type string. Then the constructor takes a message parameter and initializes the message variable with it. So now let's go through a JavaScript example for writing data too, right? So this would make it much clearer, I hope. So let's go through this example. Right, you're importing the Web3 library again. Similar to what you did in reading data, same thing we are doing here, first two steps, right? Again, we are creating a Web3 instance, right? New Web3 robston.infura.io, your Infura project ID. Then again, same thing, contract ABI, contract address. I'm not wasting too much time on this, right? Then you're creating a contract instance. We have done this before again, right? New web3.ethereum.contract, contract ABI, contract address. Yeah, so now the asynchronous function, right? This is where it gets different. So async function set message parameter is new message. It declares an asynchronous function that takes one parameter new message, which is the new message to set, right? Const account equal to await web3.ethereum.get accounts. So this retrieves a list of accounts from the Ethereum node. Typically, the first node accounts 0, right, as an array, right? The zeroth of the array, right, is used to send transactions. The first account, right? Okay. So next is const receipt equal to await my contract dot methods dot set message new message dot send from account 0, right? You're again sending it from account 0. So this calls the set message method of the contract to update the message. Okay, so this is calling the set message method, and this sends the transaction from the first account. The send method is used for operations that modify the blockchain state. Okay, and next is your just console.log transaction received sends the transaction receipt to the console, which contains details about the transaction. And finally, we're just calling the function It invokes set message function to update the message stored in the contract with string hello, comma, blockchain, exclamation mark. Right? Okay. So same thing, right? This is what you have done here. I have explained all these points to you. You can go through it again. So now we are going to use web3.js JavaScript to interact with smart contracts. Web3.js is a popular JavaScript library that allows developers to interact with Ethereum-based blockchains, right? It provides a set of APIs that make it very easy to read data and write data to smart contracts deployed on the Ethereum network. With Web3.js, developers can perform a variety of tasks, such as connecting an Ethereum node, querying the blockchain, interacting with smart contracts. So connecting Web3.js can connect the local Ethereum node or a remote node by a service like Infura. We have done this. Next is querying the blockchain. You can use Web3.js to query the blockchain for info, such as the current block number, balance of an Ethereum address, state of smart contract. Next, we are interacting with smart contracts. Web3.js provides a set of functions that allow developers to call the functions of smart contracts, read its state, and even deploy new smart contracts. Using Web3.js, developers can build decentralized applications, dApps, that interact with the Ethereum blockchain in a secure and reliable manner. This library removes away many of the low-level details of the Ethereum protocol, which makes it much easier for developers to focus on building their application logic. Right? You don't have to worry about nonsensical, small things, low-level details. You can just focus on building your application logic. So this is the smart contract that we'll go through. 0.8.0 Solidity compiler, contract my contract, state variable public message. We have done all of this. And now we are declaring an event here. This is what we are doing different, right? Declares an event named message updated. Message updated will be emitted with a new message string parameter whenever the message is updated. Events are used to notify external applications of changes within the contract. Okay. Next is your constructor. We have done constructor twice or thrice already. So the constructor sets the state variable message to the value of underscore message. Now we are setting the function to update the message, right? So function set message string memory underscore message declares a public function that takes one parameter underscore message, which is a string stored in memory, right? So what this does is it updates message state variable with the new value provided by underscore message. And finally, what's different here again compared to what we have done? Emit message updated underscore message emits the message updated event, signaling that the message has been updated. So you're emitting an event here. That's what extra you're doing here. And then finally, you have a function to retrieve the message. So you have a function called getMessage that returns the current value of the message state variable. It's public, right? It can be accessed from outside the contract. View indicates it does not modify the state of the contract. Return string memory specifies that the function returns a string stored in memory. And the function body returns the current value of the message state variable. Let's go next, right? So we'll go through an explanation of web3.js, right? So yeah, we have to import the Web3 library. Yeah, again, we have done all of this. Robston, Infura.io, your project ID, contract ABI, contract address. You're again creating a new contract instance. We have done all of this, right? Okay. So now you have to listen for events. This is the new thing we are doing here. So this sets up an event listener for the message updated event emitted by the contract. So my contract.events.message updated sets up an event listener for the message updated event. The empty object can be used to specify filter options, but it's empty here, so no filters are applied. Error event is a callback function that is executed whenever the message updated event is emitted. Exclamation mark error, that is not error usually. Then this, and else this. So this checks if there is an error. If not, it proceeds to handle the event. Then finally you have console log new message. Event returns value new message. This logs the new message to the console. Right? Event.returnValues.new message contains the new message string emitted by the event, and console error logs any error that has been occurred during the event listening process. So this is just like an example. You can use a universal remote control app to manage various devices and their functions, right? With your smartphone, you can manage your TV, your air conditioner, sometimes even your fridge. This is how this works essentially. Okay, so we'll talk about more about handling events from smart contracts, like what we just did, right? So Ethereum smart contracts can emit events that allow your application to listen for, and it reacts to specific occurrence on the blockchain. Events are a very powerful feature that will enable your smart contract to communicate with the outside world and will also trigger actions in your applications. By listening for events, your application can stay up to date with the state of the smart contract and respond accordingly. Right, so how this works, right? When a smart contract emits an event, the EVM, Ethereum Virtual Machine, will log the event data, which can then be accessed by your application. You can use a library like web3.js, what we have used, right, to subscribe to these events, and then you can handle them in real time. This helps you to build reactive applications that automatically respond to changes in the smart contract state. These can be used for a variety of purposes, such as notifying users of important updates, triggering external actions, or even updating the user interface of your application. By leveraging events, you can create more dynamic and responsive apps that seamlessly interact with underlying smart contracts. So, this is what the explanation, right? So, they emit events to log information and notify external applications of certain occurrences. Handling events involves listening for these and processing the info. So this is like setting up notifications on your phone to alert you when certain actions occur, right? You're watching a cricket match, you have notifications turned on. Wicket falls, you get a notification. This is how events are. So just to elaborate again, right? So this was your smart contract for handling events, right? This was your Solidity code. I explained each and everything in detail. You might have thought why we were doing this, right? So this was to show you how to handle events in your Solidity code, right? And this was the Web3, like JavaScript library explanation for it, right? This is what I explained to you in great detail. This is essentially what handling events is. This is just the theory. I explained the code already. Okay, so now we'll take an example of interacting with a smart contract, right? What is interacting with a smart contract? It's like using a remote control to operate a smart home device. You can check its status, change settings, and you receive notifications. We'll take a comprehensive example which will demonstrate reading from, writing to, and handling events, everything that we have done today in one example. So first, again, we'll need to connect the deployed smart contract using the contract's address and API. I've showed you all of this, right? Why we do this? This is to allow our application to interact with the contract's function and events. We can then call the contract's read functions to retrieve data, such as the current state of the contract or the values of its variables. Next, we'll demonstrate how to write data with the smart contract by calling its write functions. We have all done this. This is just a summary and showing it to you in one example how to do all of this together. Yeah, so writing data might involve updating the contract state, triggering a specific action, or sending a transaction with data, right? So we'll need to ensure we have the necessary permissions and gas to execute the right operation successfully. Finally, we have our event listeners to monitor the smart contract for specific events, right? When these events are emitted, our application responds accordingly, how I explained, such as updating the user interface or triggering additional actions. This allows us to build reactive and responsive applications that stay in sync with the state of the smart contract. Interacting with smart contracts with JavaScript. Okay, so this is your comprehensive code example essentially. This is what you should try to understand. This is more important than anything we have done here. Probably the biggest code. It goes over 2 pages, right? Okay. You import the library, right? Web3.javascript library provides APIs to interact with Ethereum. You create a new Web3 instance, right? We have done all of this, robston.infura.io, version 3, your Infura project ID, right? Then your contract API, contract address, all of this, again, we have seen how to do this. Then you create a contract instance, right? And what's the purpose of this? It creates an instance of the smart contract that allows interaction with its functions and events. And then finally, you're making the async function, right? So the async function we are exploring here is different than the other ones we have done yet. This is a pretty big async function, so let's go through all of this carefully, right? This in fact spawns over 2 pages. So let's go step by step, right? So this is your async function. So first what you're doing is reading the message. So my contract.methods.getMessage.call. It retrieves the current message stored in the contract. This is a read-only operation that does not modify the blockchain. It is executing using .call, which is free. It does not take any gas. Next, you're setting the new message. You're setting the new message. It's kind of like writing. So my contract dot methods dot set message hello Ethereum dot send from account 0. This updates the message stored in the contract. This is a state changing operation that modifies the blockchain. So it's executed using dot send from account 0, which spend transaction from the specified Ethereum accounts 0, the first, the 0th array, right? That's how this works. Transaction received. Once the transaction is sent as received containing details about the transaction, such as gas used, is returned and logged. Because this uses gas, so you need to maintain a receipt also about it, right? So this is returned and logged, like how much gas has been used. We log this. Next, what we are trying to do here, we are trying to read the updated message. After updating the message, similar thing, what we did before, we are reading it again, right? So my contract.methods.getMessage.call, again we are using this. This is used again to retrieve and log the updated message from the contract. We already had one before. Now we have written it over and we want to see the updated one. So this is why you use this, right? Okay. So next we go. This is finally we are listening for the event, right? So what we do here is my contracts.events.message updated, right? So this sets up an event listener for the message updated event emitted by the contract. Whenever this event is emitted, example, when set message function updates the message, something like that, the listener captures it. The callback function, error comma event, and following logs the new message emitted by the event. And then finally, you're just calling the async function in the next step, right? It calls the interact with contract function to initiate the interaction with the smart contract. So I hope this is understood by you because this is quite important to get, right? So this gives you a small explanation. I have explained all of this in detail. You can read this again. Again, the slides that I have there, these should help you in explaining have you not got anything in the video, and you can always refer back to the video, right? So what this does, yeah, this example shows how to interact with a smart contract, right? So you import the Web3 library like I told, an Option Ethereum test network using an Infura project ID. Next, you have the ABI and contract address, and then a new instance is created. Next, the functions are defined with get message, set message. Okay, then it reads the updated message like I told. Finally, you listen for the message updated event. And then last step, you interact with the contract using interact with contract function to execute the example. So finally, I think we are done. I'll leave you with an interactive exercise slash quiz, right? What you have to do is you can set up a development environment, Node.js, npm web3.js, then you write a script to read data from a deployed smart contract, right? Okay, and then what you can do is write a script to send a transaction to a deployed smart contract. Implement event handling to listen for specific events emitted by a smart contract. And just at the end, verify the interactions by checking the contract states or events. Just verification. This will take no time at all, right? So yeah, these will help you reinforce the concepts covered in previous section and also provide hands-on experience with tools and techniques used for interacting with Ethereum smart contracts. So next we'll move on to how to use oracles. So yeah, this is it for today, and that's it. We are done, I guess. Thank you very much.